This meeting is being recorded.
In problem 3 from chapter 5, we are asked about, or told rather, about compound X and compound Y. We're told they're constitutional isomers. So we know that they have the same molecular formula, but they're going to have a different bonding pattern or different attachments, different connectivity of their atoms. So we're told some more information that compound X possesses a carbon-carbon double bond that's in the trans configuration. So if you recall what that would look like, we would have something like this. And we have compound Y that is not stereoisomeric. So we'll think about how we could create compound Y. So let's first see if we can identify a structure for compound X. So since we're told this information about the trans double bond, we know that this would have to use up 4 of our carbons. And let's take a minute to think if we were to put our 5th carbon from the chemical formula, we know we need one more, on either carbon 2 or 3, this would create the same group in one of those vanillic positions. So we can have that if we want this to remain a stereoisomeric double bond. So we would have to place either on either allylic position, so either on carbon 1 here or carbon 4. So this is one structure that could account for our molecular formula that's given, C5H10. So this could be either this or the mirror image would be the same compound for C5H10 for compound X. Then we want to identify 4 possible structures for compound Y. So as we were doing our determination for our first structure, we realized that if we put the 5th carbon like this, we would have the same group. So this is one version, right? This is one structure that we could have for the compound Y. We could also have something that looks like this. Not like that, like this, rather. So let's see, we have 1, 2, 3, 4, 5 carbons. So then here we would have a non-isomeric structure. So there's 1 non-isomeric double bond. Here's 2. Let's see, what else could we do? So we could have in structure 3 here, we would have, again, the double bond on the end. And then we could have our carbons arranged like this. So this would be 1, 2, 3, 4, 5. And then again, we have that same result here. We have 2 hydrogens. And last but not least, we could combine something like structure 1 and 3 together. And we would have our 2 hydrogens on the end here. And then we could put this last carbon coming down here. So we have 1, 2, 3, 4, 5 carbons again in this 4th possible structure for compound Y.